And welcome back to another episode of Containers on the Couch. Today we have an interesting episode, something which I personally don't know much about, so I'm also looking forward to learn. I would like to introduce our guest, John Jackson. John, can you please introduce yourself? You do it better than I will, so please go ahead.
Thank you so much. Yes, I'm John Jackson. I'm the Principal Product Manager responsible for Amazon Managed Workflows for Apache Airflow, or MWAA.
MWAA. Where are you located out of, just a matter of interest?
We're out of Vancouver, Canada, so just a little north from our colleagues down in Seattle.
Cool, very nice. Hope the weather's also good there. Over here in Israel, it's pretty hot, but that makes no difference anyway. My name is Michael Casing. I'm a developer advocate with the ECS service team. And we are here back on Containers on the Couch. So if you're in the chat, wave, say hello, let us know where you're talking from. And we're going to be talking, as John said, something about Apache Airflow. So I'm going to let you give the introduction about that and tell us what we're going to be doing here today.
Yeah, so what we'll be discussing today is really around Apache Airflow, which is an orchestration service or an orchestration platform, and the managed version of that we offer on AWS, which is Amazon Managed Workflows for Apache Airflow. And really with a focus on, we'll give a little introduction as to what exactly, first of all, Apache Airflow is for the folks in the audience that have not had a chance to use it yet. And really what it's used for and why it's important, and also how it's relevant to, especially to the container community. And then really dig into sort of, our managed service built around Apache Airflow. And then really talk about, ways that we can leverage the integration or leverage essentially ECS Fargate to really test and do development on this platform. And then we'll also touch on some of the ways you actually use Airflow and specifically MWA in production with containers. And then we'll just sort of close it off with some, some additional resources for folks that are interested in learning more.
Cool. Ready to start?
All right. So let's start with what is Airflow, because not everyone's going to necessarily know that right off the top. So as I mentioned, Airflow is an orchestration platform, and it's become very popular for a number of reasons. One is everything you see on the in sort of the lower half of the screen here. This is the user interface. It's basically a web server, but everything you see in the lower half that describes the actual workflow is all written in Python. And there's no, even though it displays it graphically, you're actually controlling all of the steps in these orchestration paths, all with Python code, which allows you to be very flexible with how you describe the relationships between steps. It lets you be, have a lot of powerful tools for redriving failed tasks, detecting, if you have certain dependencies met or not. If you're, there are sensors that allow you to say, hey, is there a file in S3? Is this database table there? Is this container completed? And it lets you do a lot of things that way that lets you very flexibly and very powerfully describe your business case so that you can actually, and then really the observability and the ability to have that business case continue is also a big aspect of it. So
can I ask go ahead, please? Sorry.
Yes.
It looks very similar to me as one of the products that we have, which is called Step Functions, which is similar. It's kind of like a workflow. Why do our customers need Airflow and they can't only use, for example, Step Functions? What is the differentiator here?
So that's a great question. So Step Function is an extraordinarily powerful workflow tool. And really where it excels is being 100% serverless, and it can drive one task or millions of tasks just as easily. And it's really about having that sort of, very strong capability to be able to handle a bunch of integrations with, especially with AWS services. There's a long list of things it integrates to. Where it is, and it really excels over Airflow in that it is, because it's serverless, it can scale out to anything, to whatever level of number of workflows you need. So I always like to say you really wouldn't use Airflow to, for example, process somebody's logins or their shopping carts, for example, because you'd never know if it's one person or many people doing it at once. Where Airflow becomes a little bit more flexible is that, first of all, as I mentioned, you're describing these workflows purely in Python code, which allows you to have very dynamic definitions, right? It allows you to, I can say, okay, I'm going to write some code that says I'm going to create a task for every table in a database, and I'm going to go through and generate and use some filtering to decide which tables I actually want to do and which tasks I want to go on that. And it also has the ability to drive retries very easily. So built into the concept of Airflow is when there's a failure, it can retry very easily. You can very easily define that. But it is provisioned. It's provisioned on a certain number of containers. We do offer, and I'll get into it in a bit, we offer scaling, auto scaling with MWAA, but it's still running on a fixed container size. And so, you do have to, spend a lot more time with Airflow, making sure you have sufficient resources. And also, because we're running Python code, you have to make sure your Python code is written well, right? Airflow is actually importing your code and can really, it's very dependent on how well that Python code is written, how well Airflow will perform.
Cool.
So, talking about, so that's a really, and again, we're not going to be able to go into the level of depth that you'd really need to truly understand Airflow on this, but hopefully it gets a bit of an idea of where that fits in. There's many more, but there's three sort of main buckets of use cases around Airflow. The first is around extract, transform, load, or extract, load, transform, depending on which tool you're using. But basically, moving data around, for lack of a better term, right? Take some data from place A, manipulate it in some way, move it to place B. And this is services on the AWS side, like Glue, Athena, Redshift. We see also a lot of just orchestration of things like just Apache Spark. If they're running, for example, they may be running on EKS and they can orchestrate their Spark jobs from this, those sort of things. The second sort of category is really around AI/ML, really around driving your machine learning. Some of that, there's some ETL aspects to that. Sometimes you have to normalize your data and get them all prepared, but then doing things like, driving SageMaker, jobs and things like that, Jupyter notebooks, those sort of elements, really doing that. And it's a nice, Airflow pairs very well with AI/ML because it's all written in Python. And if you're writing notebooks, you're often already writing it in Python too. It's a very sort of natural way I can describe my orchestration, my workflow in the same language I'm actually defining the way my machine learning is supposed to work. And then sort of the third broad category is really around DevOps. And this is really, an area where I think might be really interesting to the containers folks in the audience, because with Airflow, I can very easily define I can stand up clusters. I can define how I want, basically interact. There is integration directly to ECS, EKS, Kubernetes in general. It's very easy to go through and define. I need to build, all this infrastructure. I can do it in a repeatable way. I can describe it in Python code, so I can make it very, very sort of dependable on how it works. I can leverage the fact that Airflow will handle these retries. So if I try and stand up a cluster and it fails, I can build in the retry logic that says, okay, well, why did it fail? And what do I want to do about it? How do I want to report it? So it's very powerful in that way. And it's, so it really gives you a flexibility that, you might be more complicated in tools, if you just want to use natively in CloudFormation or Terraform, it may be easier to write some more complicated DevOps patterns in Airflow.
Yep.
So in Airflow, and we're not going to spend a ton of time in the architecture, but just so we know sort of what we're discussing here, there's sort of four main components to it. There's the scheduler, which not surprisingly schedules the work. There's a worker that actually monitors and invokes the tasks. There's a bit of a misnomer there, even though it's called the worker. Generally, you don't do much actual work on the worker. This is where the processes that actually monitor the downstream work are done. There's the web server, which we showed the screenshot of, which is basically just your user interface. And there's a metadata base in the back end that stores the state of the system. So that's really where sort of all these components look to understand where things are happening.
And before you go into that, there was one comment which came in from Paful from the chat. It attacked us. This is an open source tool. I understand, of course, that it's a huge plus in Airflow. In other words, you can use it pretty much on any platform you want, any on premises, in the cloud, whichever cloud you choose. But this is also a very, can you tell us more about how the open source, I would say the idea of what actually Apache Airflow is and how much of a popular product it is?
That's a great call. And yeah, I'm so close to this. I just sort of automatically assume, yes, Apache Airflow is 100% open source. I'll get to in a second. Our managed version is the exact same open source software, and it is a huge plus. You can run this anywhere. In fact, we're really going to leverage that later on in this discussion. It has a huge community. In fact, it is has the largest number of contributors of any other Apache project. I think Spark is fairly far back as number 2. And Airflow has, so it's a massive community. And one of the benefits of open source is it's not so much the portability, although that's a thing as well. It's the community. It's really the fact that you have this huge number of people who know and love and contribute to this project. And it's really easy to find an answer to a question. All right. There's just a lot of people there to help you. There's a really active Slack community, which I'll share at the end of the presentation, where these incredibly knowledgeable folks will happily answer questions. And we have a bunch of our own folks that are there all the time as well, answering questions too. And that is really the community is really the strongest benefit of the using an open source platform.
Okay, thank you. And thank you, Praful, for providing your insight.
Yes, thank you. It was a great question. Thank you for that call out. Now, that being said, this is an awesome project. Lots of people love it. It's being used. There are still some challenges, and these are not probably all that unique to Airflow, but they are, challenges nonetheless. First of all, you've got to set it up and deploy this, right? It's an open source project. There's lots of ways to deploy it. You can run into trouble, scaling it and sizing it appropriately for what you're trying to do. Of course, you've got to define how your security and authentication is going to work so that, not only the people you want to use it, access it, and only in the way you wish. Ensuring that you can upgrade the platform and that it remains available and monitoring and make sure it's available to your users or yourself. And then, of course, just sort of the maintenance and monitoring, right? Is it functioning as I expect? Are there any problems or any issues? So all this stuff, when you're setting it up yourself, you have to set up, right? You have to, and that's, again, not unique to Airflow. This is pretty much anything you're going to set up your software. You're going to have to do a lot of these things.
Yep.
So it's really those challenges why we listen to customers and say, we love Airflow. We just don't want to do all those things. We'd like someone to do that on our behalf. And so that's really where Amazon Managed Workflows for Apache Airflow comes in, because first of all, we use, as I mentioned in the comment, we use the same Apache Airflow that you can download. There's no difference whatsoever. It's the exact same software. We have an in-house open source development team that contributes to, a lot of the AWS integrations, but also to the Airflow core code as well. And doing things like, contributing to, things like, there was some open lineage stuff that was done, but also just in general, like the idea that, and open telemetry, excuse me. And, but also just sort of, making sure that the project continues to improve. We address any sort of issues that that users and customers open up in the open source project, that sort of thing. But then to that open source project and that open source code, we add, take care of some of the things on customers' behalf. First of all, we handle all the authentication for you. So we do that authentication through IAM. Anyone who's used AWS knows IAM, you're going to have to run into it somewhere. So we're leveraging that as well. we're also running these resources on virtual private clouds. So this way, the Airflow resources, we provision the workers and schedulers that actually need to interact with the customer's content. We provision that on the customer's VPC. So that way they don't have to worry about, how do I access this data? How do I get it from one place to the next? We can provision these right onto their VPC, and it has access to all the data that VPC does. It also comes out of the box, it's integrated. So we run the containers on AWS Fargate, and through that we use an execution role in IAM. And this way, it's really easy to say what resources you want these MWA environments to access, because you can simply say, oh, this execution role, I needed to have access to Glue, or I need to have access to Athena or Redshift or what have you. You can do that all through the IAM provisioning. And that way, that integration makes it really easy. We also integrate to Amazon CloudWatch for all your logging. So again, you can leverage those tools to be able to monitor what's going on in the system. You don't have to, you can monitor many different environments all at once. You can use things like Log Insights to quickly scan through your logs and find information. And then we also use S3 for all the sources of your DAGs and your configurations and your things like your Python libraries that you wish to add to the system. That's all done through on S3, and that makes it a lot easier to just sort of put it as part of your CI/CD pipeline. And then, of course, we made it relatively easy to deploy. You can deploy it through the console. You can use CloudFormation, the API, CLI, CDK, Terraform, all the usual sort of ways to do that.
So we had one question from the audience. Can you integrate MWAA with other IDPs like Okta?
Yes, you can. So through that, you can use you can basically federate OAuth and Okta and things like that through to IAM, and then we would then use that. And there's actually examples. I'll have a link later on to our resources page, and you'll be able to see that. The resources page has some examples of how to integrate to our to Okta and other OAuth.
So I think it might only be me, but I'm not sure. But I think for some reason your camera has frozen.
I think so as well. Yeah, I'll
just stop your camera and turn it on again.
Sure. Let me do that briefly. Let me stop cam, start cam. Let's see if that brings. Nope, that did not help. Let's see. No, I'm still frozen on here. I apologize for that. Okay. Let me see if maybe it'll come back. And
we hear you, but we don't see you though.
Yeah, you've lost me completely, have you? All right. Well, I apologize for that. Let me. Oh, there we go. We've got
that's better. We see that's a different camera, but yeah, we see you.
No, but we've at least got something going on, so that's a little bit better than nothing. Here we can see if I rotate the camera again. Let's see if it comes back. While that
unfortunately not, you're frozen again. So I think we'll go with the other camera.
We'll go with the other camera. All right, very good. We'll do that then instead. Let me switch cameras again, and we'll switch that out. Okay, so I will look this way instead. I'll move this over while I'm doing this. So, okay, so moving on. So I really want to touch on a bit of the MWA architecture. So, really, it's, as I mentioned, we're leveraging the customer's VPC. So we're using these Fargate containers to do that. We're running the Airflow schedulers and workers on the Fargate containers. And then for each environment, we create a single tenant service VPC. And that single tenant VPC is able to, so for every single environment, it's got its own metadatabase, its own web server cluster, a separate RDS proxy in front of it. So, these things are all set up to be able to, create this isolated environment and allow us to provision these for you, but still make sure that the workload runs on where the customer's resources lie.
Okay.
And to that end, there are some dependencies we use. So I mentioned we use CloudWatch for logging, S3 for the DAG storage. Airflow uses a queuing system to sort of organize tasks in a certain order. So we do that as well through SQS. And then, as we're running these on Fargate containers, we need to actually provision the containers. And so we use ECR for those Airflow images. So,
and will these containers appear, like, for example, as tasks in the customer's account in the cluster?
It's a great question. So no, actually they won't. We actually they attach to the ENI of the VPC, but you don't actually see these clusters in your account.
Okay.
So as I mentioned, we're helping out with the with really the deployment of these systems, make it easy to set up. It makes it easier to upgrade, and we have in-place upgrades. So you just select the newer version, much like you would with Kubernetes and EKS. Select the new version, it goes ahead and does it. We do have auto scaling of these containers, so we actually look at the Celery queue, as I mentioned, the queued tasks, and we can adjust the number of. We can add additional Fargate containers as needed. All that security again through IAM is done, and then also which can, again, as was asked, we can federate that to other services or other authentications like Okta, and then using all the Airflow metrics are published to CloudWatch. All the logs are published to CloudWatch. It makes it very easy to set up alarming and anything that might be of concern there. Okay. So, sorry, you're.
So there was one other question which came up also from the chat as well from Deep Learning Ninja. Are there any, do you know of any big machine learning workflow orchestration projects that are using MWAA? And cost analysis, I don't know if we have information that we can share, but if the other question you have, it would be good answer.
Yeah, I mean, there absolutely is our machine learning workflows using this, both with services like SageMaker, but also a lot of sort of custom ML that's running on EKS or ECS. I can't go into specific details on sort of individual customer usage, but I do know that's a very popular pattern being used. As far as pricing, it's really going to depend. The pricing for Airflow on MWA is very straightforward. You can, basically take the number of tasks you need, determines the number of workers you need, and then it's just the size of the environment is more defined by the number of workflows you have and the complexity of those workflows.
Okay.
So one other thing I get asked occasionally too with this is really around well, I'm already running Airflow on EKS, so why use MWA? I've already got Kubernetes, it's working. It really is about, Airflow is intended as an orchestration system. It's not really intended to run your specific workloads necessarily. It's meant to sort of, tell something what to do. When it succeeds or fails, it does the right thing depending on that. It kind of doesn't matter where Airflow is running, right? It as long as it's orchestrating your Kubernetes jobs or your ECS jobs, having to sort of offloading the work of, dealing with upgrades, dealing with, provisioning, dealing with monitoring and authentication, offloading that work makes it a lot easier for to really focus on the important stuff to your business and not worry about, how do I keep Airflow running?
Or the underlying infrastructure. Exactly.
So, let's really talk about, the sort of what kicked off this discussion really was around a blog post we did around running MWA local runner on ECS Fargate. And so first I'll explain what local runner is. And that is, when we developed MWA, as I mentioned, we're already running the same open source Airflow. So we want to give customers the ability to do just local testing, right? So take the Airflow version, which, I mean, it is just running Airflow, but Airflow can have different libraries, different configurations. There's lots of ways you can configure Airflow. So what we did was we published in GitHub a Docker-based version of MWA. That's the same Airflow version that we're using, the same open source version with the same configurations, and a few utilities to make it easier. So a big part is really testing, for example, your Python libraries, right? You want to make sure those are all, there's no conflicts. You want to test, pip install them, all things like that. And you may want to run sort of, test some plugins that you're writing or that sort of thing. Local runner makes that really easy, right? Because it's just, you just, do, do a pull of the GitHub repo, run your stuff on your local Docker. It's great.
Okay.
And so, and this has become really popular, local runner. And so one thing we heard from customers and users was maybe we're not allowed to use Docker. We don't have Docker on, it's not part of our IT infrastructure. Or, we don't have access to, I need to test it against these AWS resources that I don't have access to off my laptop.
Yep.
And so what we did was we took the same local runner image that you can run locally and just put a blog post together about, well, you can run this on ECS Fargate or ECS, really ECS anything, and go ahead and test it. And you can do it with the exact same resources MWA uses, right down to the execution role. Because again, we're running MWA on ECS Fargate as well. With a couple of tweaks to the execution role, it'll work well with your own Fargate. You can test it, do all your testing on AWS in the same context that the production, the MWA environments are. Because if you're just doing development, you may not need, MWA is multi-availability zone and multi-database, and it has, it has a separate web server that'll, provide sort of, separate access to the user interface for different users. But you may not need that if you're just writing a workflow. And I just want to write this workflow and test it with my EKS cluster and see if it works.
Okay.
And so this really addressed those issues. And then beyond that, it gives you a few other tricks as well. One is you can do some automated testing now. As I mentioned, you can do things like testing requirements and your plugins and things like that with Local Runner. Now you can do that right on Fargate. You can have as part of your CI/CD pipeline, okay, we're going to spin up this little tiny Fargate instance of MWA's Local Runner. We're going to test our Python libraries to make sure they're working correctly. And only if that succeeds will we publish those new libraries to the actual production MWA environment.
So it allows customers to streamline their workflow in a very easy way.
Exactly. And another thing is if you have a lot of developers and you don't need those developers don't need the sort of the high availability of MWA, you can use this to scale. Have many developers have their own, a little tiny ECS version of an MWA local runner that they can access, they can test, they can do everything else, and you can do a bunch of them at a lower cost. So this gives you the ability to have many of the same benefits, obviously not the authentication and the scalability and the high availability of MWA. Yeah. But if you're just writing some Python code, then it's probably more than what you need.
Nice, very nice.
And the one other thing it gets you too is all these developers that are testing against this, because you can define this using CloudFormation or Terraform. You don't have to rely on, oh, well, this developer is running on an M1 processor and it's working one way on Docker. And this other developer has got Windows and Docker's not working correctly at all for them, right? You don't have to worry about them figuring that stuff out. I can just say, you know what? Do you need a little dev cluster? Great. Here's the dev cluster. You can work on that. You can interact with it. It's not going to bother anyone else's work. And when you're happy with it, we can then be comfortable getting those workflows into the production environment.
You were speaking before about the fact that sometimes customers or users don't actually have access to Docker. I was working before I was a developer advocate with as a solutions architect in AWS, and we had some financial customers that actually used only workspaces, remote desktops. And when you use workspaces, you can't really run a virtual machine or a Docker environment on those. So they had to come around with all kinds of workarounds, connect to a Cloud9 instance, run their jobs remotely on a Cloud9 instance, all kinds of things like that, which they actually had to find workarounds in order to actually get access to some kind of a container runtime. And this is actually what actually provide them a very, very good solution for this. Very nice.
Yeah, and actually a great point too is that, while we did develop this blog post around, replicating Airflow and MWA's configuration of Airflow on ECS Fargate, you can repurpose this to basically run anything on Fargate. Like, there's a lot of benefits to doing this same model for lots of different platforms. So I would encourage folks to take a look at it and be creative and see what other things you can do on it, because there's lots of cases where, as you said, Docker is just not an option, but you need to interact with containers.
So before we go further, I want to just welcome everybody that might be joining in the middle of the stream or catching us on the replay or the recording. We're talking today about managed workflow for Apache Airflow on running on ECS. And we're here with John Jackson. My name is Michelle Casing. And with that, I'm going to hand it over to you for the rest.
Absolutely. So, one thing we really want to talk about as well is sort of, how does this ultimately work, right? So, as I mentioned, you can take the exact same MWAA configurations that you're using today, and you can go through and say, okay, well, I'm one of these execution roles that have access to my downstream resources, and I have configuration options I've set that access things like secrets manager for all your passwords, or accessing your email services, for example, for sending notifications. And I want to access all that stuff and basically apply that to a CloudFormation or a Terraform template that we've provided in the link in the blog, and we'll provide that link again at the end. And use that to provision an ECS Fargate cluster. And we're actually using Aurora Serverless as the backend database for these, because it's very scalable and very, very lightweight. Because as I mentioned earlier, Airflow requires a RDS database as the backend.
Yeah.
And then one super cool thing you can do, and I don't know if everyone knows you can do this, is use the ECS execute command, AWS CLI command. And it lets you actually remote into these Fargate containers and interact with them as if they were right on your desktop.
And when we talk, the ECS execute command is a feature within ECS, which allows you to just kind of open up a shell directly into a container either running on Fargate or ECS on EC2. And I'm going to post actually the link for the documentation here.
Yeah, exactly. And and it's super easy to do. In fact, we can probably, if we have a minute, I can actually share.
That would be awesome.
Share what that looks like when you're interacting with an MWA environment. So let me go ahead and share my VS Code window here. And because I don't want to have everyone watch me type, I will just copy and paste these commands in. Because as exciting as watching someone type is, you probably want to forego that. So in this case, I've already defined a region. I've got my MWA local cluster, which was the name we used in the blog. You can call it whatever you like. The task ID I've already defined earlier, and then which is just the task ID from the ECS Fargate cluster. And it uses the session manager plugin, and you can see now we have a bash screen. So I can go through, and now I'm in my Airflow cluster. So if I go through and LS, I can go into the DAGs folder. I can see that information. I can do things like monitor the logs. So I can just use the tail command to monitor. For example, I have a DAG on here that's reading from Redshift. I can monitor that.
And a DAG stands for, sorry, because
I apologize. Yes. So a DAG is a directed acyclic graph. So if I let's say I just take a look at what this looks like here, for example. So you can see how in this case it's essentially just a Python. It is just a Python file, right? So it uses a bunch of Airflow libraries, among other ones, whatever ones I want to use. And I can pull some configuration options. In this case, there's variables you can store in here. And you provide certain arguments like how often it's going to retry and things like that. But at the end of the day, there are predefined sensors and operators. So in this case, I have a key sensor that's verifying that an S3 bucket is available. But I can also define things just as Python tasks. So I just put this little task decorator in front of my Python function. In this case, I'm grabbing a Postgres hook and talking to the database. And then the directed acyclic graph is really that the workflow that you saw earlier. And so again, I can just have a DAG decorator, which provides a unique identifier. You can provide an interval as either a cron or a time span. And I can just say, then you can define your tasks as, again, as these built-in operators, your own operators, or just Python functions. And then you define a relationship between them. And you can have as complicated a relationship as you so wish. So that's what's ultimately running those workflows that you saw on the screen. And so, through this, I can then, I can have as many of these. I can open up multiple of these. What's great is I don't have to have network access to those containers to interact with it. I just need to have AWS CLI access and obviously the permissions to access this container.
And the correct configuration in order for ECS exec to work, which is SSM and the right permissions and the role in the container as well, for sure. Yeah,
exactly. And the blog post explains how to do that. So once again, even if you're not using our specific, Airflow at this time, although we hope you try it out, it's a great sort of overview of how to use the execute command and how to configure a Fargate container that lets you then interact with it, run your own code, bash into the system, and really interact it with it in a way that is a lot easier, frankly, than having to sort of remote into an EC2 instance.
correct, for sure. How does the upgrades of these, either I would say not, also the containers which you're provisioning of these tasks and the actual MWAA work? Because there was a comment on the chat that Praful had that there are some risks by upgrading or modifying an existing MWAA instance which is deployed.
It's a great point, and actually, that's a big part of what this local runner on Fargate helps you with. So let me switch back to my my presentation. That's a great question, because you're absolutely right. Any upgrade, it potentially has some risk, right? Because you're fundamentally changing the version of the software that is being used, and so really talking about using this local runner system, because it is using, again, it's the same configuration resources, but there's no risk to this, right? If it works, it doesn't work, you can modify it and change it. So I'll talk to you a little bit in a second, but really inserting something like this into your testing pipeline, right? Making sure that before I upgrade the version of MWA, I provision the target version of Airflow that I want to upgrade to. I provision that on local runner with the exact same settings, same library, same everything. Make sure it starts up correctly. Do my validation of it. Did Airflow start correctly? Is the container reporting is healthy? Again, you can remote into it, make sure everything looks the way it's supposed to, and then only when you're satisfied that it has met that criteria, then you do the in-place upgrade. Now, MWA will roll back if the in-place upgrade fails, meaning that your Airflow environments won't start up. MWA will roll back the environment and roll back to a snapshot of the previous database. Because one of the big things with Airflow is when you do an upgrade to a minor version, it's going to change the database schema somewhat. And so when we do that rollback, the first thing we do before we upgrade is take a snapshot. And if it doesn't work, we roll back to that snapshot. So, that helps a lot. But there's cases where maybe something's not working. Maybe your workflows aren't working as expected. Like the actual upgrade will work fine. But let's say one of the operators you used to use, they've refactored it, in the open source community and have changed, maybe the import location. And so now that one particular workflow won't work as expected because you need to change the import line. Using local runner or local runner on ECS Fargate makes that a lot easier and a lot safer.
Nice.
So really want to talk about sort of more general. So we've talked a little bit about using the ECS Fargate for the containers and things like that. But really want to talk about generally containers and Airflow, and particularly MWA, because as I mentioned, Airflow is really meant to do it's supposed to be the orchestrator. It shouldn't really be doing too much heavy lifting on its own, ideally. But Airflow is great for orchestrating containers. And there's tons of Airflow users and customers that use exactly this pattern, and it works really well because you've got the orchestration system that just is its job is to make sure things are running and understand what to do when they stop. And then your containers have all of your business logic. They have all that, they're running your ML model. They are running your sort of custom Spark code. They are running whatever it happens to be, right? Airflow can optionally provision these containers, or simply just add a pod to your existing Kubernetes cluster, run whatever work you need to do on it, monitor for how it does, and then move on and do the next thing. And it gives you a lot of scalability that way. And so this is I really encourage customers that have like a lot of heavy workloads to do, or even just sort of a lot of customized workloads to do. It's a great pattern to use. You can leverage the fact that containers are there and available, and let Airflow do what it's really good at, which is handling the orchestration, complex or otherwise, and understanding what to do when the task it told to happen didn't respond the way you wanted to. And I did touch on using containers for CI/CD. And again, this really goes back to the previous question, which is how do you make sure everything's going to work? Airflow is written in Python. If you provide Python libraries that conflict with something Airflow expects, Airflow may not work correctly. It may not work at all. So really testing your Python libraries, testing your code, leveraging things like, spin up an Airflow in, local runner on ECS Fargate, have it work, test it out, make sure that do some unit tests, make sure it works the way you expect it to before pushing it to your production environment is extraordinarily powerful. And with a little bit of upfront work, it can be basically seamless, right? You can insert it and say, when someone submits a new an update to your GitHub, your Artifactory, whatever you're using, before it pushes it runs basically the CloudFormation or Terraform template like we've shown in the blog post. It runs these things and tests and makes sure everything's working correctly. And only after you're satisfied that it works the way you might even put like a burn-in period, have it run for a few hours or a day or whatever. And then only if it's satisfied does it push that out. This is really, really good. And really, automating anything you do more than once is super powerful. So if this is something you're doing all the time, leverage the power of these containers, leverage the power of tools like CloudFormation and Terraform. To really, automate that testing, make sure it's going to work rather than trying to fix something after it breaks later, test it up front. And it almost, if it saves you one problem, it's paid for the effort right there.
Exactly.
So really before, because we're right around the time, we're going to wrap up.
Exactly.
Really want to leave with a few resources. And I mentioned some of them. First and foremost, as was already shared in the chat, we have the blog post that we were discussing here about running Amazon MWAA local runner on ECS Fargate. Please take a look, try it out. It's very straightforward. It's also not a bad intro just to Airflow. If you just want to have a quick way of spinning up an Airflow cluster and just trying it out and playing with it, it's a very easy way to do that. MWAA is very easy as well, but if you're already in sort of, you want I don't want to really spin up that sort of thing, and you already perhaps are working in with ECS or EKS, this might be the way to do that. Really around, there's also our MWAA documentation, which is has a ton of examples. It has examples of orchestrating EKS, examples of orchestrating ECS. There's a ton of great code examples in there for folks to look into. I mentioned as sort of one of the benefits of open source in general, the Airflow AWS Slack channel. This is not, it's part of the Airflow Slack. It's a channel where a lot of discussions around integrating to AWS, but lots of discussion around MWAA and local runner as well. Airflow community is fantastic. They are extraordinarily helpful. They're extraordinarily knowledgeable. Definitely, especially if you're new to Airflow, there's a whole newbie channel in there as well where you can ask questions and don't feel self-conscious about asking it because it's your first time using it. The community is fantastic. We do have our resources page that includes both the blog post that you have here and a ton of other ones. I mentioned the blog post around integrating to Okta and other OAuth and SAML authentications. There's blog posts on that. There's blog posts on CI/CD pipelines. Please check it out. There's a ton of cool stuff there. Obviously, local runner was a big part of what we have here, so I put the link. It's also linked in the blog post. And I wanted to sort of work. There was when you get into using MWAA and Airflow in general at a bigger scale. I mentioned earlier how really it's dependent on the better your DAG code, the Python code, the more performance you'll be able to get out of the system. And so I linked in a presentation I did over on the serverless office hours channel, talking about running MWAA at scale and really how really small code changes make a big difference. And so, hopefully folks get a chance to take a look at these resources as well and dig into it. Airflow is incredibly powerful, incredibly flexible. I think if you haven't had a chance to experience it yet, I'm sure you've heard of it. And, it's a really good opportunity to take some of these resources and learn about it.
And I hope that answers your question, Deep Learning Ninja, who actually had the question about MWAA at scale. I would suggest that you go have a look at the previous session, which John had over here, gave on the serverless office hours. I'm sure you'll be able to ask. And if not, you still have any questions above and beyond that, please feel free to reach out either to him or to me and be more than happy to help you out.
Absolutely. And you asked about the scale. So, the short answer is it really depends, right? You can write, in the demonstration I've linked to here, we have some guidance about how many DAGs typically you can define on a small, medium, or large size environment. For example, our guidelines about 250 DAG definitions on a medium environment. But in the demo I showed here with some coding techniques, I was able to get to about 350 DAG definitions and running it very effectively. Conversely, you might have one or two Python DAG, or Python files that define your DAGs. And if it's written in certain ways, that might be it. That's all you're going to get. So it's highly dependent on, yes, there you go. It depends.
It depends, of course.
And so really, but leveraging, so one thing I can say for certain is leveraging things like Local Runner, which either on ECS or otherwise, testing your DAG code. There's tools that are built into Airflow that let you see how long a DAG takes to parse. That sort of defines sort of how many definitions you could define. Now, as far as how many tasks you can run, the math is slightly easier on that. So, on a small environment, we can do about 5 tasks per container. A medium environment is 10 tasks per container, and a large environment has 20 tasks per container. So, if you have, you mentioned sort of, let's say you have 1,000 tasks that need to run. The maximum we can do on an environment is 25. So you can only really run 500 tasks at a time. And that's if they're running long enough that they have time to sort of to line up. So, and I think you mentioned something about 30 minutes. So if you had very roughly, if you had 1,000 tasks that take 30 minutes each, then you could run them every hour, right? Because you could have first the 500 tasks would run for 30 minutes, and then the next 500 tasks would run for 30 minutes. And that's your hour. So that's roughly, obviously there's some overhead there as well. So it's not quite as straightforward as that, but that will get you sort of in the ballpark of those tasks.
Cool. Perfect. As you said, coming to the close of the hour, we're going to end a little bit early today. Are there any closing remarks you would like to share with us before we close up for this? And of course, before I say that, of course, all these links will be available, of course, as part of the show notes available on our YouTube channel. So don't forget to subscribe. This will be available as soon as the recording's done.
Yeah, I really appreciate the opportunity. It's great. We know that Airflow and containers work really well together. This is not only do we build the service on Fargate containers, we know many customers rely on it to orchestrate their container jobs. And it's really Airflow and orchestrating work on containers is just a natural fit. And I know there are some other options to do that, but it's really, I would encourage folks that are maybe have a lot of Kubernetes containers to orchestrate or ECS containers to orchestrate, or they're just interested in learning more about Airflow to go and take a look at, see what it can do. Provisioning on an MWAA environment, it's very straightforward. It's literally a couple of clicks in the console. So if you want to try it out that way, it's actually even easier than running through the blog post example we have here. It's really it's really easy to get into. Try it out, see if it will solve some of your orchestration and workflow challenges, because a lot of it is an extremely popular open source tool with a great community and lots of folks to help you along the way.
So thank you very much. This was a awesome session. I learned a lot about Apache Airflow and MWAA, of course, as well, and how they work with containers. John Jackson, a principal product manager, is that correct?
That's correct.
In AWS with MWAA. Thank you very much for joining us. My name is Michal Casing. Thank you for joining us from Containers on the Couch. Don't forget to hit the subscribe button and a like for the video if you enjoyed it as well. Don't forget, of course, to join us next week for another episode from Containers on the Couch. At the same time, be here with our Kubernetes counterparts, which will be giving you an interesting session. So thank you very much for joining, and we'll see you later.
Thanks, folks.
Bye, everyone.